Back when I wrote my first line of code, I started with web development and I got to know about these technologies. And if I had to look back and figure out which is the part which I like the least, but is one of the most important things, is software testing. I don't like it a lot because obviously it takes up a lot of time. And if you have done the thing right, which somebody like me always does, then it makes you feel like that you're wasting your time writing it, right? But at the same time, if you look at software testing, this is probably something that has got so many bugs, even in code base that I've written or refactors I have made in future, which prevents these bugs. So this is like an important thing to be. And out of all those testings, I feel, especially for full stack applications, one of the most important testings is end-to-end testing. So end-to-end testing is nothing but just giving, your script, your testing script, a browser over here. So this is like a browser, or it could be like a web app, it could be like a mobile app or something. And your script is the one that is programmatically controlling the browser, and it's doing actions as if how a user would do, based on selectors, based on, different things which are possible. And then you get three outputs, basically: pass, fail, or flaky, right? Flaky is something that sometimes fails and sometimes passes. Fail is then, obviously it fails, and passes is that it passes. End-to-end testing is something which is a very necessary evil. If you have worked in software development, and especially with, front end on mobile applications, you know that this is a notoriously hard thing to do, not because it's hard to implement, but because of the constant updates, the selector changes, the things, the flakiness that is there. I feel like end-to-end tests are probably one of the most flaky tests out there, right? So you need a lot of tooling, a lot of interesting things to make them work properly. Now, this is where I feel AI comes into play. See these recent models that are getting released, even the open source, the free open source one, Kimi Cape 2.5, for example, Opus 4.6, a lot of these models are actually making a lot of jump in the vision capabilities, right? So one capability of a model is obviously the text-based LLM, its intelligence of how well it can respond to your question. The second capability, which is in these models, is its vision-based capabilities, right? Which is basically how well does a model understand what it's seeing on the screen, right? And these AI models now, especially for end-to-end testing AI, they are at a junction where they are good enough that you can use AI for vision-based testing as well. So you can technically create end-to-end tests with AI itself, right? But of course, running your test all the time with AI would be very slow, because obviously these AI models, especially the ones which are expensive, are very slow to talk to the provider. Like, this is slow. If this is like Claude server, then your AI not only has to see on the screen like what's going on, it takes a screenshot, it sends it to Claude, or it sends it back like what it's seeing, and then it can perform some action, right? So this whole process is extremely slow. So ideally, how an end-to-end testing should look like is something on these lines, where you use an AI system, you create a test, you make tweaks to this, and once your tweaks are done, you get the code, and then you run it in CI, right? Just like how you would do typically for your normal test that you are writing. Now, the benefit here is that because this AI is very strong in vision, you can quickly update the tests anytime they become flaky, or anytime there is something which you feel is not doing the way it's supposed to be. This AI can just be prompted with natural language, right? That you can just update whatever is going on. Now, the problem is that how do you do this? Because even if you look at things like Claude Code or Cursor, or any of these state-of-the-art tools which are there, they don't really allow, or they're not really built for testing. They're built for software development, but not for testing. So I was finding a good enough solution for this when I came across my friends over at Lambda Test, which is now known as TestMu, which is basically a testing AI agent cloud system. Now, this is actually very interesting because this technique that we have discussed over here is exactly what they implement, and it makes a lot of sense for me to use them for anything end-to-end testing which requires agents and which requires vision. Let me show you what I mean by that. So when you sign up for a free account for TestMu, you will be taken to their dashboard over here, where you will have these bunch of things that you can use. In this video, I want to show you about this Kane AI agent, which sits exactly which we discussed over here. So this has been made in such a way, this agent has been made in such a way that it can do both the things that we discussed, that it can use AI with natural language autonomously to create the test, and you can then make tweaks and do whatever, get the code, or the AI itself can watch you do the things and create tests on that, right? And you can just give it control beyond that specific thing. So let me show you both the scenarios, both the things. I'm running this company called Fermion, where we help a lot of educational institutes take their business online. So I have this one domain called demo.fermion.app, which can be used for testing, right? This is what we use internally for testing, for giving client demos and so on and so forth. So I'm going to show you an example on this website. So see, there are a couple of things that I like about this. First is this author browser test, right? Which is me, in a way, manually showing their AI system what the test is supposed to do, and then the AI system can take over. And the second one is just natural language prompt, which I can start off with, right? So let's say I start off with a natural language prompt, and I say that, hey, you need to go to demo.fermion.app, hit the login button, and log in with user email as Mehul and password as the same. Right, so I've reset the password to match the email for now, and I'll select desktop browser, but you can see that you can do this for mobile browser as well as for mobile application, which is also pretty interesting because if you have your APK files or an actual app, you can use that for testing exactly like how I'm doing it. And that is even better, right? Because at web, at least, if you're using your computer, you're writing your code, you can just do it right away. But mobile is even more uncomfortable, that you have to switch the devices as well. So anyway, once I have this prompt, I'll press this button over here, which will take me to the session screen. Now, the interesting thing here is that, see this Google Chrome browser, which appears over here. This is a virtual machine which is running in the cloud, right? So the good thing about this is that once you have specified the prompt in TestMu, the whole thing takes place in a virtual machine. So that means that I can spin up 100 such scenarios, right? I can spin up 100 or even thousands of such scenarios, which probably my team or somebody has written down, and I can just spin off every single agent for them, get some code for them, create sort of like a repository of those tests, and run them anytime I want. So you see, it creates like a summary of what it needs to do, and it's asking me to approve the plan. I can do that, or what I can also do is, if I want to check out ahead of time, like if I want to add, you can go a little crazy here. You can add like an API call as well between the test itself, which I'll show you like how you can add steps between the tests. You can add like a bunch of secrets. You can add like a database query. For example, let's say, you want to be smart, that you make an account, but you also want to verify that it exists in the database now, because the UI could say, yes, it's fine, but you want to be absolutely sure. This is where you can also include stuff like these database calls or API calls to retrieve real data, right? Or maybe you just want to take a small shortcut and make a mutation in the database directly. So this advanced setup allows you to do these things. But anyway, for now, I will just approve the plan and I'll just show you what this does, right? So what's happening right now is that they are using an AI system which looks at this browser, which is by the way a real browser happening or running in the cloud, and it's taking these screenshots every single time, right? So whenever it's doing something, what it's doing is it's using over here, when it's creating these tests are created with vision models, right? So you use a vision model, you take a screenshot of the page you are at, take screenshot, right? Once you have the screenshot with you figure out the next step. And this is actually very useful in case you have like a bunch of things. You can see like already it opened the URL, which is fine. Now in terms of clicking the existing user login button, I did not specify it that this is the button at the top right. I just specified it that you have to go and log in, which has a couple of advantages if you think about it. See, if the AI itself fails at this step, that also somewhat puts you in a situation that would a user be able to discover that in the first place then also, right? Because you're effectively, the AI does not really know about your product, right? And if you just give it a natural prompt that you have to log in, it also makes it possible for you to check that how your experience is for an end user. But you can see this little cursor that we have over here, this green cursor. This shows that, Lambda test agent was able to see that. Over here, you can see now it clicked on, this email tab, because you can see right now we allow both the functionalities, right? Phone number login and email login. Again, the AI was able to figure it out on its own thanks to the vision models that it saw, like, I can click on this email. Then it added like the username, password, it clicked the button, and now it is inside the dashboard itself, right? So this is a dummy dashboard inside Fermion, which allows us to do a bunch of things, right? So I just gave it a task which required it to just log in into the dashboard itself, right? Now let's say that I want to make this a little bit more complex because this is a little bit too simple, right? So what I can item in the left sidebar automatically appeared. So it's not like it's just observing what I'm doing. It's actually using the same AI feedback loop to check alongside the vision model and alongside course. Let's say this is a document that lists everything, what needs to be done, problem statement, something that you will get from your product team, from your features team, which is working on a feature, and you have to now implement these things. And it has everything like user stories, stuff like this. And what you can do is drag and drop this PDF into KNAI and ask it to come up with the test cases that you want. So if I upload this PDF and I hit this button, you will see it'll start processing your PDF and it'll start to think about what can be done. You can see now it's coming up with a few important tasks, like these couple of tasks are must have that 22 test cases in this case. So if I create and automate this, and if I link it with one of my existing applications, let's say something that is already there on TestMeo. But anyway, once you're done with this, what you can do is you can save these bunch of, you'll also see, but this is past sessions as well, which you have this to show the AI what's going on. If you're starting 50 to these sessions, you click on the test I was talking about initially, that it's expensive, it's slow, and it's usually done against testing. So in order to do that, in for your tests. See, so hopefully this test should pass because I gave it as on Linux, Mac OS, they will video as well, right? So you'll have to execute need in order to need it for doing a organized in a folder-like structure on E2E testing than doing it by hand.
There's a level of working with AI that most people don't even know exists. And I don't mean some kind of advanced engineering thing. I mean a way of working with these systems that completely changes what's possible for you, and most people are sitting one shift away from it. If you've been using AI and the results feel inconsistent, sometimes it's great and sometimes it's kind of useless, well, that's real. That's not in your head. And it's not the whole picture. There's something going on that nobody really explains well, and I think once you see it, a lot of things are going to click for you. So here's what we're going to do today. I'm going to walk you through what I think of as kind of the AI proficiency ladder, where most people are, where the unlocks happen, and actual steps that you can take to start moving toward that next level. I'm not going to be giving you tool recommendations or prompt tricks. This is a peek at the mindset shift that separates the people getting massive value from AI from the ones still wondering what the hype is about. And it starts with something that almost nobody talks about clearly enough. Here's what nobody says clearly enough. Work has changed. And I don't mean jobs, I mean work itself, the way we get things done. For our entire lives, work has operated on one model. You spend a long time learning expertise, years and sometimes even decades, and then you apply that expertise over and over. Learn, apply, repeat. That's how it's always been, and it's worked really well. It's worked really well. But that model is breaking, and what's replacing it is genuinely exciting. AI doesn't just change what tools you use at work, it changes the shape of work itself. I used to be able to be an expert in one or maybe even two fields. Well, as we all know, with AI, you can operate at a very high level across 10. And if you think about that for a second, 10 fields where you can bring real capability to bear, that's not a small change. That's kind of a fundamental rewrite of what's possible for us. And most people are still trying to use AI inside the old model. They're treating it like a fancier Google or a code autocomplete or better spell checker or something like that. And that would be like saying electricity is for sewing machines. You're not wrong that electricity would power a sewing machine, of course, but if that's all you see, you've dramatically limited what you can even imagine doing with it. And there is just so much more to imagine. So if the game has changed, where are you actually playing? That's where this ladder comes in. So I think about AI proficiency as sort of a ladder, not 5 rigid levels, but more like zones that you slide through. So I'm not trying to build a complete absolute construct around where you are. These aren't grades or certifications, but there are recognizable patterns in how people interact with AI, and understanding where your behaviors cluster helps you see where you are and where you're headed. So level 1, you're asking questions. ChatGPT, write emails, summarize spreadsheets, maybe even build writing. You're exploring, you're wondering, you're combining things in ways that nobody's shown you. Later, but they're not where most people need help right now. All the way into 3. So level 2 is where smart people get trapped, honestly, and I want to talk to you about why. Here's what the level 2 or zone 2 looks like. You've been using AI for real work. You've had some wins, maybe some great ones. And you've also had some disasters. And because of that, you've started to build opinions. And those opinions sound sort of like, it's inconsistent. I can't trust it. You've turned observations into verdicts. This is where most people need to hear something that sounds soft, but I promise you, it's the hardest thing on the list. So the shift from level 2 to level 3 isn't a new tool, and it isn't a better prompt. It's actually just one word: wonder. When you're in level 2 and AI gives you a bad result, your instinct is to judge. That didn't work. AI isn't good at this. But when you're sliding into level 3, your instinct changes. It becomes something a little bit more like, that didn't work. I wonder if I framed the problem wrong. I wonder if it would work if I broke it into pieces. And I wonder if I gave it too much information, or if there's a completely different approach that I could take to this. That word wonder is the whole shift. And I want to be clear about what I mean by this. Wonder is not optimism. It's not blind faith in AI. It's the willingness to keep exploring when the obvious path didn't work. Think of it this way. It's the difference between someone who gets a power drill, press the direction, and maybe that could help, so you try it. And then it might help you triage 12 emails and figure out which one to reply to first. It might, I don't know, tell you that partial ownership. I guarantee you things start to change. The results get better. The frustration drops with you about why it takes what it takes. What you're actually building is intuition. I'm not where all three, and you can't skip one. So don't try to speed run the ladder. That's really not the point. This is a
Okay, so what is the best model in the world right now? Is it GPT, Claude, or Gemini? I think that is the wrong question to ask. So there was a recent study in which researchers tested frontier models like Gemini, Claude, and GPT on real-world tasks, the type of tasks that knowledge workers like analysts, lawyers, and consultants do. And they found out that the best frontier model was able to achieve only 24% of those tasks. Now, these are the same models that score about 90% on the benchmarks that everybody argues about online. So either the benchmarks are lying or we are measuring the wrong thing. And I think it's the second one. And that's exactly what I want to talk about in today's video. We need to discuss what actually determines whether an AI agent works or it doesn't. And it's not the model itself. It's what's wrapped around the model that almost nobody talks about today. So let me give you a word that I think is going to define 2026 the way agents define 2025. The word is harness. An agent harness is the infrastructure that wraps around the AI model or LLM. It manages what the AI can see, what tools it can use, and how it recovers from mistakes that consultants, lawyers, and investment analysts do on a daily basis. Each task takes a human professional about 1 to 2 commands, read files, right? We're talking about standard command line tools like grep and cat. These are the type of tools a human would use, right? Now, the results were interesting because the accuracy that catches and corrects failures. It's a robust, layered.
Let's talk about a ridiculously easy way to get better results from a coding agent using a software practice that's like 20, 30 years old at this point. This is red-green refactor, or in Sun Willison's weblog here, this is red-green TDD. TDD stands for test-driven development. TDD's probably most prolific advocate is Mr. Kent Beck here in Extreme Programming Explained. XP was a software practice developed in, I don't know, the 90s, 2000s, and it advocated extremely aggressive use of unit tests, or aggressive is maybe not the right word, but everything in the software practice was built around unit tests. As Simon said, the most disciplined form of TDD is test-first development. You write the automated test first, confirm that they fail, and then iterate on the implementation until the tests pass. And as Simon says, this turns out to be a fantastic fit for coding agents. I have definitely found this to be true. But what do the red and green here mean? Well, red essentially means write a failing test, and the CI goes red. In other words, any automated types or tests that you've got on the repo will be, at that point, red. You've written a failing test to verify that the thing is going to work when it's built. This might be that you're fetching something from a database using some kind of SDK, and you're testing the SDK, and you basically write that the fetch is going to work before you've even implemented the API method, before you've even implemented the DB schema. And then once that red test is in, you then write a green implementation to make the CI go green again. In other words, all of your unit tests go, yep, tick, that looks good. The important thing is that this is minimal, okay? Because in the next step, we're then going to refactor the code that we just wrote in order to make it prettier, to factor it into the shape that we want. And we get the luxury of doing that because we have already made our CI green. And so we have a set of tests that allow us to test that our refactor doesn't break anything. Now, for experienced software engineers, you're probably going, okay, why does this matter more now than it did 10 minutes ago? Because red-green refactor has always been an amazing way to build software. So why are we talking about it in the AI age? Well, for me, I find it really, really comforting when I see an agent doing red-green refactor. Let's imagine this sequence of events where the agent writes a failing test. I can see in the CI, or I can see in the agent's output that the test failed. I then see it write an implementation, and it doesn't change anything about the test, doesn't try to like fake it to make it pass or anything, and the test goes green. Now, if it's a reasonable agent, it's pretty hard for it to fake that. And this means I don't end up reading a lot of the tests that are created during my red-green refactor loop. I maybe skim them, especially just the titles to understand what is being tested, but I don't necessarily read all of the implementations. Because I've seen it go red and then go green, I feel pretty confident that it's a reasonable test testing the thing that it's supposed to. And of course, once this loop is over and it's committed to the branch, I then go and QA that chunk of work, so I catch anything that the tests might have missed. And at that point, I can generally flush out any bad tests if there are any. You can find all my skills at the link below. To make this work, I have a TDD skill that I like to to invoke when I'm building these features. You can find all my skills at the link below. Now, there's stuff in here that I'm not talking about in this video, but the main focus of this is using the, the red-green refactor approach. So down here, I get it to do an incremental loop. For each remaining behavior, write the next test, see that it fails, and write then the minimal code to pass, and then pass. The rules are that it should only do one test at a time. I find that this is a really important caveat because it means that you then don't end up with a huge splurge of tests. This is one thing that LLMs love to do, which they love to create huge horizontal layers. And then they'll try to one-shot an implementation that passes all 90 of those tests. So they will do one massive file edit where they'll add 90 different tests. Now that's possible, but you do end up with a lot of crap tests, in my opinion. So just getting it to focus on the thing that it's implementing at the time, and then writing a single test for that, then writing the implementation to do that, another test, another implementation, another test, another implementation, you end up with tests that are really important for actually guiding the implementation. In other words, this one test at a time idea is really focused on improving the quality of your tests. Then once I'm done with this incremental loop, I then say after all tests pass, look for refactor candidates. But again, that's probably the topic for another video. So yeah, red-green refactor is a thing that you have to know how to be able to do. And unsaid throughout this whole video is the fact that feedback loops matter so much with AI. Because AI is so eager to create code and find the fastest solution to your problem, you need to impose some back pressure on it to essentially keep it in a stable state. And strong types like TypeScript, of course, or unit tests or things like that can really assist you in getting high quality code. And so I think code quality is actually more important than ever because, I mean, if you've got a low quality code base, the LLM is going to replicate what it sees. Just like any developer out there, it will be happy to play in the mud if what you have is mud. Now, if you're digging this stuff and you like what you're seeing on this channel, then you should check out my newsletter, which is where all of these videos go. And also, got a low quality code base, the LLM is going to replicate what it sees. Just like any developer out there, it will be.
No, I think if I could give one piece of advice to my younger self, it would be one of the cornerstones that I teach in Maker School and Make Money with Make, which is outputs lag relative to inputs. So if you provide a lot of inputs, you will not see the result of those inputs for a little while. And so if you have a very tight feedback loop like I do, and I like to see results with the things that I do very quickly, if you spend a week doing something, you don't see those results, it's not because the week that you spent doing the thing has not yielded any results. It's because life just has some little built-in lag. You're not going to see those results for like a month. So if you really wanted to be smart about it, you would get some assumption that what you were doing is the right thing. Okay, you would believe it really deeply because you've thought a lot about it and you built some logic out. And you say, if I submit 10 Loom videos every single day to creators that I admire and I message them over Instagram, LinkedIn, X, whatever, mathematically I should get a result. If you can ground some assumption, and then if you can just do it for a very long period of time, eventually those inputs will catch up to those outputs, and then you will start seeing the results. When I started my brand journey, it was actually quite a while ago. It was almost 5 or 6 years ago. I started blogging every single day. So I wrote a blog every day for 30 days. It was part of the big blog challenge between me and a few of my friends. One of my friends making YouTube videos, and one of my friends is doing blogs like me, and another one is doing something else. And I did like 30 blogs. And I broke my back over it. It was like an hour and a half, 2 hours a day, me writing and researching and spending a lot of time and taking away from a lot of other things I could have been doing, to be honest. Probably should not have started that to begin with. Anyway, at the end of the 30 days, I had like 5 views or something. It was pathetic. It was so silly. Nobody had looked at any one of my blog posts. So what did I do at the end of the 30 days? I said, well, I'm not seeing any results. And because I'm an intelligent person, I have a tight feedback loop. I'm always about iterating, right? So I didn't see any results for this, so I should iterate and I should do something different. Well, the fundamental problem that I had there, the mistaken error, was that I didn't realize to what degree outputs lag over inputs. Because a year or so later, I looked back on blogs that I'd written a year before, and dozens of them were ranking on the first page of Google for their search term. I was getting hundreds of hits to my website, hundreds of opportunities to sell products related to those blogs. Imagine if I had just continued doing that one blog post a day. By the end of the year, I probably would have been one of the more prolific bloggers on the internet, like legitimately, because all of this stuff is so exponential. Same thing with my YouTube channel. So I took that lesson that I learned about inputs lagging over outputs, and then I just said, okay, screw it. I'm just going to continue making YouTube videos every day for a month, and I'll worry about where I land later. So I did it for a full 30 days. I learned that the market rewards you, but it rewards you later. So I took that knowledge with me from my failure in blogging, and then I made the YouTube. And then now that I've actually stuck with it, now that I'm consistent with it, now I'm one of the bigger creators in my space. And certainly I think probably the most respected. So yeah, I guess just outputs lag over inputs. If you believe space, and certainly I think probably the most respected. And then now that I've actually stuck with it, now that I'm consistent with it, now I'm one of the bigger creators in my space. And certainly I think probably the most respected. So yeah, I guess just outputs lag over inputs. If you believe deeply that what you are doing is, and certainly I think blogging, and then I made the YouTube, and then now that I've actually stuck with it, now that I'm consistent with it, now I'm one of the bigger creators in my space. And certainly I think probably the most respected. So yeah, I guess just outputs lag over inputs. If you believe deeply that what you are doing is the right thing, then don't worry too much about that feedback, at least in the first month or so. Give yourself a little bit of grace and a little bit of space to take more time to do those things and achieve those results. And I think if you just multiply the amount of time you think it'll take to see something by 2 or 3 or something, that's probably a good heuristic. You're probably a lot more likely to actually succeed realistically.
All right, we have a very serious problem here in America. This is something that I need to make a video on because not enough people are talking about it. It is a violation, a deep violation of ethics. And it just makes me sick, honestly. The behavior I'm seeing, not only is it not ethical, it could be downright felonious. So you're probably asking yourself, well, what the heck are we talking about? What is this felonious behavior? Well, you wouldn't believe what Google just recently discovered. Google DeepMind and the GTIG, that of course stands for Google Threat Intelligence Group, have identified increase in model extraction attempts or distillation attacks, a method of intellectual property theft that violates Google's terms of service. Yes, you heard it here first. The company in which has stolen the world's data to sell back to us in the form of generative AI is upset because there is someone stealing from the generative AI. Oh my gosh, you cannot make this up, dude. The fact that Google is even attempting to cry intellectual property theft, this has to be one of the most rich ironies I have ever seen in my entire lifetime. It's not just Google. OpenAI is also blowing the whistle on the alarm, okay? OpenAI believes the best future is one in which we move forward with democratic AI. By the way, by democratic AI, they certainly don't mean open sourcing more of their models, okay? Wow. That would be way too democratic. AI that is shaped by the principles America has always stood for. In advancing democratic AI, America is competing with the Chinese Communist Party, determined to become the global leader in AI by 2030. That's one reason why the release of DeepSeek R1's model at the Lunar New Year 1 year ago was so noteworthy. As a gauge,